a transmission of random process through LTI filter. So here we have to see uh, linear time invariant system. Linear time invariant system. So what is linear time invariant system? So linear time invariant system, if you give same input to the system, the outputs are different even the time period is changed. you know so linear time invariant systems are respond differently to the same input, okay, because we are giving same input, but the different time, but outputs are linear. So linear time invariant system, you are giving the same input. Example, if you're giving a value of 5, 5, 5, 5, but it responds differently in different times, but the outputs are linear. Linear, what is linear? X and y axis, that I already said about the water tank. Even the time period is over, the water tank is filling regularly. The values depends upon, value will be continue, and it is depends upon the current value depends upon the previous value, that is called as linear. So linear time variant system. So linear means the outputs are here linear. So output depends upon the previous value. That means current value depends upon the previous value and it is continuous. That is called as linear. So linear time variant system, that because why it is time variant, even the time change, it will be act as a different response with the same input, that is called as linear time invariant system. So linear time invariant system represented by impulse response. So impulse response, this will be represented as okay, then x of t, that input signal to the system, and y of t can be written as. So if x of t considered as the input to the system, then y of t considered as the output of the system. So if the output of the system y of t, then also equation y of t equal to the integral of minus infinity to plus infinity to h of alpha x of t minus alpha d alpha. So the integral started minus infinity to x plus infinity to x of alpha h of t minus alpha d alpha. The above integral is called convolution of h and x. So and we can write y of t. Y of t is nothing but output of the system. X of t is input of the system, and h of t we can say as impulse response. So that is equal to x of t and h of t. Even the impulse, it is look like the formula is a into b equal to b into a. So similarly, the y of t, if you given impulse response and multiply of x of t, that is also equal to input and then impulse response. So for discrete time system, the output can be written as y of n equal to h of n plus x of n. So x of n into h of n. So both is equal. That's just now we see. So if you going to write the equation, summation of k minus infinity to plus infinity to impulse response h of a, then x of n minus k, that is equal to x of k h of n minus k. The impulse function defined as for LTI system. You just take the diagram. X of t, that is h of t, that's the impulse response of LTI system, linear time invariant system. Then y of t. So y of t, that is equal to h of t into x of t. So same system, that is equivalent with the other system. So even previous system it is shown continuous time period. That's a T. And next one is shown as a discrete time period, that is N. So see here, this one is T and this one is N. So x of t is continuous time period LTA system, and next one is discrete time LTA system. So x of n discrete time period, that is sent to impulse response of LTI system, and finally we will be get the output of y of n. So y of n equal to impulse response and input system. So LTI system with the random inputs. Uh, for example, if we consider the y of t is equal to x of t, x of t. So, that's a single system. So, if x of t, y of t jointly wide and stationary, then the mean value you will be get it e y of t equal to. So, for the equation will become for mean function. Okay, so integral of minus infinity to plus infinity h of alpha x of t minus alpha dx. So this one is for the I just now said the mean function can be written as mu y, and actually mean function it deals only one signal, so that signal might be x or y, anyone. So x is input here or y is output here. So it deals with only one signal. So mean y of t equal to mu y equal to or mu x. Either it will be, we can use this one or this one. That's a formula. So you can integral of minus infinity to plus infinity h of l d. So that if you're going to apply in mean value, you can change x or y. That is a into b or b into a. Both are equal. That's shown by LTA system. Similarly, mean function also you can use x or y. Then autocovariance function xy t1 comma t2. So that will be changed as, even you can use t1 t2 or t2 t1. So both are equal. So that is in linear time invariant system for covariance and correlation function. Okay. So that equation we can represent it as rxy t1 comma t2 e of x t1 y2 equal to e of x t1 integral of minus infinity to plus infinity to h of alpha x of t2 minus alpha d alpha. So the equation comes continuing e of integral of minus infinity to h of alpha x of t1 and t2. So the remaining parts are shown in the slide. You can just watch. So final equation is integral of minus infinity to plus infinity to h of alpha rx t1 minus t2 plus alpha d alpha. So previous one is covariant function rxy t1 comma t2. Then that's the equation. Finally, we'll be getting ry. That's output tau is equal to h tau minus h minus tau into rx tau. So the above results conclude that x of t and y of t are jointly wide and stationary. Because jointly wide and stationary, there are two variables are joint, the x and the y. So this above function will be concluded as jointly wide and stationary. So third unit completed. Okay, thank you.